Hi class, this is Neil, and this is lesson 6 on slope. So let's take a look at the do now. A character in a video game has 250 hit points of health. They were just struck by a poison spell that deals 14 points of damage every turn that passes due to being poisoned. So we're supposed to write a function giving the character's health, h of t, as a function of the time t in turns. Now, although it looks different, we can think of this problem the same way we thought of the problems involving patterns from the previous lesson. So if I think about our turns, let's make a table that might help us see what's happening here a little bit better. So think about the turns. Before I even start my first turn, so when I'm in turn 0, how much health do I have? Well, you're right. You have 250 hit points of health. Now, we're going to call that our health. And remember, that is h of t. All right, so after one turn, how many health points do I lose? Yep, 14 points. So after one turn, I have 236 health points left. What happens after 2 turns? Well, after 2 turns, I would have 14 less than that. So 222 health points. Okay, so we should start to see our pattern here that we're losing 14 points every turn. Okay, so for our function, h of t, well, we start with 250. And now if every turn I'm losing another 14 points. So if I went to turn 3, I'm really losing 3 times 14 points. I'm going down, so we're going to represent that with a negative 14. A way that we represent that algebraically is we would say our turns here is our variable, or that's what is changing, and every turn we're losing 14 points. So here's my function h of t. That really goes with part A. What will the character's health be after 6 turns? Well, what we're really looking for here is h of 6. Okay, so h of 6 equals 250 minus 14 times 6. Now, if you need to, turn to a calculator. 14 times 6 is 84. So we would have 250 take away 84. 250 take away 84, so my health is, at that point, $166. All right, so I'm actually going to erase what I have here, just so I have some space for part C. Just draw an arrow. This goes to part A. All right, how many turns does it take until the character dies? Ooh. Okay, remember there are no such thing as decimal turns, so take that into consideration in your answer. All right, so a character dies when they have 0 health left, or health points. What we're interested in is, when does 0 equal 250 minus oh my gosh. Sorry, I had some stylus issues here. So when does 0 equal 250 minus 14t? Now, to solve this equation, I'm going to subtract 250 from both sides. All right, I have negative 250 equals negative 14t. Divide both sides by negative 14. Okay, that cancels. I'm going to get t equals. Now I'm going to have to use a calculator for this because I can't do that and I don't want to do that the long way. So t equals 17.85. Now remember, you can't have a decimal of a turn, so let's round that up to 18. So after 18 turns, the character dies. Okay, for our lesson, we're taking a look at slope. Okay, so for this question, we're asked to use the line graph below to answer each of the following questions. All right, well, for part A, we're asked to determine the slope of the line segment shown below. Now, there's a few ways we could do that. What I like to think about it, one way that I think approach this problem is think of slope as rise over run. Okay, that's one way to think about slope. Slope, if you remember back to Algebra 1, is often represented with that letter m. So m equals rise over run. All right, rise is really the vertical change. Run is the horizontal change. Okay, so if I look at this line segment, my rise, well, if I look at that line, I think automatically, well, it's going down. So I'm going down here, -3. And the negative is what helps me indicate that I'm going down. And now my run here is how much I'm going over. I'm going over 6 units. So if I represent that slope as rise over run, the rise is -3, the run is 6, so that simplifies to -1/2. All right, for the second part, I'm sorry, not for the second part, another way we could think about that problem, if we weren't thinking about it as rise over run, is what is the change in the x and the y values? So another way we find slope is this formula. Slope, or m, is equal to the difference of the y's, so y2 minus y1, over the difference of the x's, so x2 minus x1. Now we need to have some points for that to work. So, sorry about that. So our point on the left here, our x is -2, our y is 8. Our x for the point on the right is 4 and 5. All right, so our difference in our y's, our change in our y's. So we just have to decide what's our first y point, what's our second. This is a little bit arbitrary, so you can decide it in whatever way you want. So if I say that my y2 is 8, my y1 is 5, then I'm going to say that m equals 8 minus 5 over. Now, if our y2 is over here, our x2 has to be over here, so that's -2, and our x1 is here, -4. Okay, when I simplify that, I'll get 3 over -6, which is the same, -1/2. So either way, we end up with the same slope. Now, what you choose as x2 and y2 and x1 and y1 doesn't really matter. It's a little bit interchangeable. You'll get the same result. All right, for our practice, we're asked to determine the slopes of each of the following lines graphically and algebraically. All right, so graphically, I'm just going to sketch my rise. So here's my rise, how much I'm going up. Here's my run. So remember, rise over run. My rise here is 8. My run is 2. So graphically, my slope is 4. If I simplify that, 4 over 1, 4. Okay, algebraically, we're going to need our points. So this first point on the bottom left is the point 3, 2. Our point up here is the point 5, 10. All right, so difference in the y's over difference in the x's. All right, so my y2 then, doesn't matter what you decide to be y2, but I might make this bigger number the y2, it's y1, makes this x2 and this x1. So I'm going to have, sorry, I keep writing the m equals (10 - 2) over 5 - 3. So m equals 8/2 or 4. So as you see, I get the same result. Checkpoint 1 is up to you. So you're supposed to do the same method there. All right, and for checkpoint 2, we're just given points here. So what I recommend you do is use that algebraic formula.